Now we're going to look at something called the rational zero theorem. And what this is going to do is give us a list to break down what values could be zeros of a function. Instead of going to the calculator and factoring, this is what they did before the TI-84 and the 83 were like awesome tools that everybody got to use. So it goes with this setup, and it helps you figure out like the fractional zeros. So you're going to list P over Q, which is the factors of your constant term, that C term at the end, and the factors of the leading coefficient. And then we're going to make some fractions and simplify them down. So if you hate fractions, I'm sorry. All right. So in our expression x cubed plus 2x squared minus 11x minus 12, we're going to list the constants factors. So the constant in this case is 12. The leading coefficient is 1. So all the ways to make 12 is 1 times 12, 2 times 6, 3 times 4. And then we want all the ways to make our, and these are all like the plus and minus of everything. And then the same thing for leading coefficient. To multiply to get 1, we multiply by positive 1 times 1 or negative 1 times 1. So what we're going to do is write this out as a way to express all the possible rational zeros. So that means the factors of 12 over the factors of 1. Which, when you have factors of 1, that's nice and you should like jump for joy. So we have positive negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, positive negative 12. Then we're going to put that over the factors of 1, positive and negative 1. And this list can be simplified down to, in this case, just the positive negatives of the whole numbers. And then what you would do is you would start testing values to see what works and what doesn't. So we're going to do that with x equals 1 and x equals negative 1. So whole number positive 1 in the box, coefficients 1, 2, negative 11, negative 12. Bring down 1. 1 times 1 is 1, 3. 1 times 3 is 3, negative 8. Negative 8, negative 20. So that's not a factor. Let's try negative 1. So negative 1, 1. Negative 1, negative 12, 12, 0. So x minus 1 is a factor. So we can write this out as the result of x minus 1 and everything that's left over. And remember, your exponents will drop by a degree. So now I'll start with x squared. And then we could factor fully to write out our expression in fully factored form and to find the rest of the zeros. So to factor x squared plus x minus 12 would mean that I would have x plus 4, x minus 3. So our fully factored form would be x minus 1, x plus 4, x minus 3, which would give us zeros at negative 1, negative 4, and 3. Oh, positive 1. My bad. Okay. Almost done. Okay. Yes, almost done. All right. So another example, we want to list the possible rational zeros for our expression. So that means we want to list the factors of 3 over the factors of 2 So to multiply to 3 is positive negative 1, positive negative 3. To get 2 is positive negative 1, positive negative 2. So what that means is I can have, and this is where you have to do a lot of like careful tracking of what you're working with. So 1 over 1 is 1. 1 over 2 is a half. 3 over 1 is 3. 3 over 2 is 3 halves. And you can list them whichever order you want. You could keep them in like actual numerical order. So 1, or you could do a half, 1, 1.5, 3, or you could just list them in whatever order you work through. And now we're going to start testing some zeros because we want to find ones that work. So I prefer to start with 1 and negative 1, but it's really up to you. So 2 times 1 is 2, negative 1. Negative 1, looking at the 2 from before, negative 7. No, negative 1, sorry, negative 9. 1 times negative 9 is negative 9, so I'm going to get a negative 12 as a remainder, not a factor. Let's try negative 1. So I'm going to copy my coefficients again. Negative 2, negative 5, 5, 3. Oh, that should be negative 3 on the end. And 0. So we do have a factor. So we'll write out the start of our factored form by saying x plus 1 times everything that's left. So I'm going to drop down a degree. So that means I'm going to start with an x squared. So 2x squared minus 5x minus 3. And you want to factor completely our 2x squared minus 5x minus 3. So I'm going to use my little cheat method. Okay, so that means that our fully factored form is x plus 1, 2x minus 3, x minus 1. So that would mean that our zeros are 1, negative 1, and 3 halves. So if we were to check some different ones, if we went to positive 3 halves and put that in our synthetic division box, you could get a 0 that way as well. So what I would like you to do is try examples 3 and 4, and then I will put up some answers for you to look at. Okay, here is one set of work that you could do for example 3. And your final factored form would look like this, and you could have those in any order. You could also, and last year I started with 1 and then negative 1, so 1 wasn't a factor, but negative 1 was. And then I had a different polynomial to continue to factor, but I ended up with the same result. So you have some option for variation here when you're comparing work with classmates. Doesn't make you wrong or make them wrong as long as you can get to the same end result. And then for this last one, I am going to go through this one with you and kind of model a shortcut to do a whole bunch of these the synthetic division without having to write 10 different synthetic division charts. You can do it with one big one. If you don't like it, you don't have to use it, but I figured I would present it to you. So you're going to start with like a side T chart, and we're going to use that after we figure out our possible zeros. So we're going to do factors of 6 over the factors of 1, and this F1 and F6 is nothing like official for notation. It's just to help me remember what I'm doing. So my leading coefficient is 1, So that means I really just need the factors of my constant. So positive, negative 1, 2, 3, and 6. So I'm going to just start testing out my values. So I'm going to copy my coefficients for across the top. And what I'm going to end up doing is I'm going to skip showing this row because you could really just do it in the calculator. And I'm going to write down the results of every row. And we're going to test a bunch. You can do it this way to test for multiple zeros if factoring's not your thing. And a lot of times I'll either just start with all the negatives and go through, or do like I did this time and go in the pairs, the positive, negative of each version. So what I'm going to do is 1 times 1, or we copy the first column. 1, 2, 3, 4, 5, 6, 7, 8. So we copy the first column. And then what I'm going to do is 1 times 1 is 1, plus negative 1 gives me 0. 1 times 0 is 0, plus 1 gives me 1. 1 times 1 is 1, minus 3 gives me negative 2. 1 times negative 2 is negative 2, minus 6 is negative 8, so not a factor. And I'm going to do it again. Negative 1 times 1 is negative 1, combined with negative 1 gives me negative 2. Negative 1 times negative 2 is 2, plus 1 is 3. So you're always going back to that top row. Negative 1 times 3 is negative 3, plus negative 3 is negative 6. Negative 1 times negative 6 is negative 7, or positive 7. And no, multiplying, not adding, is positive 6, minus 6 is 0. So there is a 0. We could then go and start factoring, but you could also test some other ones, and you should get them to work as well. And but let's write out what our factored result is. So I'm going to have x plus 1 times negative 2x to the third plus 3, or no, I forgot my leading term, 1x cubed, sorry. Wrote it in a different color and I ignored it. X cubed minus 2x squared minus 3x plus 3x minus 6. And then you can continue on a factor from there, but that's, so if you want to do like factor by grouping, you could, but you can continue to do synthetic division, but now to this other row. And then what happens is you have fewer rows to do. So what that looks like is this. So I'm going to test 2 now. So 2 times 1 is 2. Minus 2 is, oh wait, no, that's not what it did. So what we're going to do is we're going to continue doing some synthetic division with this chart and see if we can get any other zeros to pop up. So what I'm going to do is just run through a couple, and I'm not going to talk them out completely, and you can work on them at your own pace at the same time. And then what you can do is you can start to see, like, this is definitely not going to cancel out with 6, so I'm just going to skip moving on. And you can see a similar pattern start happening. So if you did start somewhere else, you can kind of go through and start synthetically dividing with a few of the terms and realize like there's no way with the coefficients and the constant that I have that I'm going to get stuff to cancel out. And you can just kind of like start stopping where you're at. And then in this case, you would want to go back and factor. So in this case, I am going to factor out an x squared, leave myself with x minus 2, and then factor out a 3 and have x minus 2 again. So now I'll have x plus 1 times x squared plus 3 times x minus 2. And then we will want to just double check to make sure that we can't do any more factoring. This 2 times 2 is, oh, I have a sign error, so I'm going to double check this one because that should show up in our table. So 2 times 1 is 2 is positive 1. 2 is 3. 6 is 3. 6 is 0. So I did have an error. So we have 2 zeros in the chart, so that could have saved you a few steps because you could have written out x plus 1, x minus 2, and then continued on from there. You could have started with this one and then had a different trinomial. So, but we have 2 of them, and that let us get a little more simplified, or you can double check yourself with your factoring. But this is our result. Okay, I will have a practice assignment posted for you, and we will definitely practice this a bunch in class.